Alright guys, so welcome to today's tutorial video. In today's tutorial video, we will finally take a look at how this Gura dash move was done. Alright, so we have a bunch of stuff right here. So we have two local scripts, we have one server script, and we have a remote event and some visuals right here. Alright, and we also have some visuals in the lighting, so we have two color correction effects, but we'll get to them later on. So let me just give you a short overview of how this thing works, alright? So this Gura script right here, this Gura local script, is going to detect when you have pressed a certain key. This will lead to this remote event being fire server. This fire server will lead to a reaction of this script, and this script will fire to all clients via this remote event, and this fire all clients will lead to the visualization of this Gura dash move on this local script right here. Alright, that's basically how it works. And now let's get into the details. So right here, we have a variable UIS, and this refers to the user input service, which is responsible to detect any user input. So key input, mouse input, controller input, whatsoever. In this case, you want to know when an input has begun, all right? So basically when you have started inputting something, when you have pressed a key, for example, when you have pressed the mouse button, when you have pressed a button on your controller, so things like that. And when this is done, we receive two arguments. The first one is the input itself. So a type of input can be anything, so it can be a key, mouse button, a controller button, whatsoever. The second one is called game processed event. I'm just going to use the acronym GPE, and this basically stands for the case it tells you whether this input was done on purpose or not, or was done while interacting with in-game elements or not. All right. So if not GPE, then this basically means that this input was not done while interacting with in-game elements. Okay, and by in-game elements, you guys can consider things like the chat, GUIs, shop. So all of these things fall under the category of in-game elements in this case. Now, this next if statement right here checks whether the input was a key and that key was the Q key. That's basically what is being checked on right here. And down here, we refer to the replicated storage, so game gets source replicated storage, and then wait for child Gura remote, and then fire server, alright? And this fire server, as I've told you, is going to lead to a reaction of the server script right here. So we are fire serving with this argument Gura move. I think that this is not really necessary, so you can keep this empty if you want to, and then you can just easily leave those checks right here. So not leave them, but delete them. I'm sorry. Yeah, you can delete those checks when you want to get rid of this argument right here. So it is just I'm just used to adding arguments inside of here. But in this case, we only fire server once. Therefore, it is totally fine that you leave those arguments right here. Delete them. I mean, yeah. So like that. So you can do that. It is optional. You do not have to. Now, right here, so inside of the server script, we are referring to this Gura remote the same way as we have referred to down right here. And we have now making use of this on server event, okay? And this on server event, as I've told you, is basically the reaction of to a fire server. So when this Gura remote, which we have just referred to, is being fire server, then this on server event happens, and this event, it gives us two arguments. Well, not two, but only one now, because the second argument was basically the argument inside of here, but we have just deleted it. Therefore, we can get rid of this one as well. So we only receive one argument now, and this argument is the player who has fire served. Okay. Now, right here, we are declaring a variable called target, and this is going to be set to nil, means to nothing. All right. So target equals nothing at the beginning. Now, I have added a comment right here saying finding target, and this is basically what happens in those lines, okay? So we are now looking out for a target, and we have two ways to approach this. The first way is via raycasting. So we are basically setting up a ray, and then we are looking out for people who are intersecting with that ray, who are touching that ray. And if someone was found who has like intersected the ray, touched the ray whatsoever, then this person is the target. Now, if nobody was found, so nobody was touching that ray whatsoever, then we have a second approach. And a second approach is basically picking out a player who is nearby, all right? And those are the two approaches right here. Now, let me explain this in detail. So, this raycasting stuff, In order to do this, you have to first of all set up this raycast params.new. So raycast parameters.new is basically like a template of settings which you can fill up right here. So the first setting we want to fill into this parameters template is the filter type, which is going to be blacklist. So blacklist, you guys probably know how blacklist filter works. So everything which is on the blacklist itself is being filtered out. That's basically how a blacklist works. And right here we are basically adding filter just tenant instances, means we are adding stuff into the blacklist. And the stuff we are adding into the blacklist is our character itself. So if we happen to touch the array by ourselves, then we are being filtered out, all right? So that's how this blacklist filter works. Now right here, we are setting up the array itself. So workspace colon raycast, and then inside of those brackets you basically add a bunch of arguments. The first argument is the start position of your array. So you can imagine a array something like this, so some kind of line right here, right? So let's pretend that this is your array, and let's say that your array starts right here and ends somewhere right here, okay? So this is basically your array. Pretend that your character is standing right here. So this is your starting point, and then this is literally the point where your character is facing to, right? So pretend that your character is facing to this direction and starts here. Then your array basically goes to into the direction your character is facing to. Of course, not infinitely long. So we have also declared the length of the array right here. So basically, your starting point is our humanoid root parts position, and the ending point is our humanoid root parts C frame, the look vector. So basically, the direction our character is facing to multiplied with 30, so 30 studs from our look vector. So basically, 30 studs from our starting position into the direction we are looking into. All right. So this is basically how you can imagine a ray. Now, if someone touches this ray or walks through it, then this player or this NPC is being detected. All right. So this is what happens right here. Wait, I've just forgot to mention the third argument, which is just yeah, which are the settings. All right. So first one is the starting point, second one is the ending point, and the third one is or are the settings which we have just set up right, and which is just all about this blacklist stuff. All right. So it's filtering, blacklisting, whatsoever. Now, if something has touched that ray, means if ray. So this basically describes the case of someone touching the ray, and ray.instance parent is a model. Now let me explain this. So when something has touched the ray, then you can basically get this something, so this particular thing which has touched the ray via ray.instance. So when something touches the ray, then it usually is the body part of a character, or yeah, when we of course pretend that only characters and NPCs, players, whatsoever, are only able to touch our ray, then only body parts are those parts who are touching the ray. All right. So the humanoid, as an instance, is not physical. Therefore, it cannot touch the ray. You know. So I hope that you are understanding what I'm trying to point out. So those are the body parts right here. They are physical. All right. You can see them. You can touch them whatsoever. And this is, for example, this humanoid is not physical at all. So it is just an instance right here which holds a bunch of information about this yeah, dummy right here. So ray instance refers to this body part which has touched the ray, and ray instance, basically body part dot parent, is a model. All right. Now if you take a look at this, the structure of a character model, then you'll see that we have a bunch of body parts right here, and body part dot parent is basically the character model itself. Okay, so this is basically what we are checking for. So we want to check if the body part's parent is actually a model itself, because you have to imagine at this point we still don't know whether the thing which has intersected our array, which has touched our array, is a character, is an NPC, or is a player, you know. So we do not know that yet, and we can know it by making the assumption that radar instance is a body part, and that this body part is located inside of a model. So by making this assumption and by checking whether this is true, we can really tell that this has to be some kind of character model. Okay, and now the third argument Oh no, no, no. The third requirement is that this character model contains a humanoid because this is literally the final piece of evidence to really make sure that this is a character model. All right. So, Ray instance, basically body part dot parent. So we are referring to this character model once again, and then find first child. So we are looking out for something called humanoid inside of it, and if it is there, then we can really tell that this Ray instance right here is a body part of a possible target. All right, and then we declare target to Ray instance dot parent. So body part parent. So the character model. Okay. Now, if nothing intersects the ray or if nothing touches the ray while we have set it up whatsoever, then we have another approach, as I've already told you. Wait, and this approach is that we are checking for people who are nearby. All right. So if target is still nil after this code, means the target wasn't found because the target wasn't because the target is usually declared down here, and if it is still nil, then it means that the script didn't get to this point. All right, and this means that it has failed those checks, and this means that nothing has touched the rate. So that's basically the chain of conclusions you have to follow in order to understand this. Now, if target is nil, so if this did not work out, then we want to loop through the workspace by using get descendants, all right? And get descendants is not like get children. So get children is like this superficial type of loop. So it only gets these instances, but get descendants literally gets anything inside of here, all right? So this, but also this, and this, and everything inside of those instances. And if there's something inside of those instances, then inside of, so you hopefully get the point. So it literally gets anything inside of the workspace. Doesn't matter where it sits, all right? It just has to be inside of the workspace. So that's basically how get descendants work. Now, if one of those instances is a model, first requirement of a character model, the second requirement is that it has a humanoid. So it contains a humanoid inside of it. So that's literally the second requirement. And those two pieces of evidence, they're enough to already tell that this has to be a character model, all right? And the third one is just there to really exclude our character from being targeted. So if V, which is a character model after this point, does not equal our character, then we're going to proceed, all right? So I think that I didn't make this clear enough yet. So what we are trying to target right here is a character model. So we are looking out for a character model inside of the workspace. Therefore, we have set up those two requirements, which we have already set up here as well. So the first one is that the instance is a model, second one is that it contains a humanoid, and the third one is just there to not target our character. So down here, we are comparing distances. I think that I should lower this one because we have 30 right here, but 60 right here. So well, it makes no sense, So we have just doubled the range, but that's not something we would like to do. So right here, we are comparing distances, as I've told you. So we are referring to this character model's humanoid root parts position, then minus our character's humanoid root parts position. So basically the distance in between those two character models, the magnitude. So this magnitude converts this distance, which would have been a vector 3, to one single number, all right? And we can now compare this number. So if the distance itself is below 30 studs, then we want to target somebody new. Not somebody new because, oh my god, not somebody new. So we are then going to target someone, all right? So that's what happens right here, target equals V. Now, when those two did not work for whatever reason, so you might be alone in the game and still trying to do this, all right? So in case this or those two did not work out, we still have a check right here. And this check really makes sure that there has to be a target. So if target is not nil, so if target is not nothing, then we want to fire all clients and then we want to add the damage, so all of that stuff. So this basically means if your target is still nil after this part, you're not going to have those visuals. You're not going to have the move, all right? So you're going to have nothing. That's what happens right here, all right? So down here, as I've already told you, we refer to the replicated storage. and then to this Gura remote, and then we do a fire all clients. So we are fire clienting to everyone with the task to Gura move visualize, and then basically the performer of the attack and the target of the attack. And after 1 second, we are dealing damage to the target. All right, so it is very important that you only handle the visuals on the client and not the damage as well. So only handle the visuals and not the damage. All right, that's basically why I've added this wait, because this wait, so this 1 second right here, it is literally this 1 second in which all of the visuals happen, and then after all of those visuals happened, we want the damage to be done. That's basically why I've added this wait right here. All right. Now, the final part now is this Gura visual script. Now let's take a deeper look inside of this one, alright? So this seems a little bit long, but we're hopefully able to deal with this. Alright, so here we are. I was just AFK, alright? So, yeah, we are referring to this Gura mode, so on client event, you guys know about this. So, basically, the event when this remote event has been fire cliented, alright? What we receive is the value. So basically, what I call the task, alright? So that's the first argument of our firewall client. Not the second one, I'm sorry. Nah, the first one. I was right. The second one is the performer, and the third one is the target, alright? So if the task is to remove visualize, then all of these things are going to happen. We can even get rid of this as well. So delete this, and then delete the end at the end, and then get rid of this one right here as well, because this Gura visual stuff, it only fulfills one purpose, and that is to visualize this one move, alright? That's the reason why we could do that. Now, what happens right here is that we're referring to our target's humanoid, and then we're referring to the walk speed, setting that to 0, and we're doing the same thing for the jump height, and then we are doing this stuff once again for our performer, and this is just to make our performer and our target unable to move. Right here, we are setting the humanoid root part C frame of our performer to something completely new, and this new C frame, it has our position as the base, and then this second part right here is the position it is facing to, all right, and this is going to be the target. So this line right here makes our performer face towards our target. That's what happens right here. Now, down here we are referring to an instance called Gura Dark instead of lighting. So lighting Gura Dark, and then we are enabling this one, all right, and this one is basically, are we able to see it? No, it was because there we go. Yeah, something like that, I guess. All right. So it basically has this dark filter over your game. That's what happens right here. So this is just for effects, for the sake of moves whatsoever. Now right here, we are creating a part which is going to be a ball, which has the size 0.5 on all axes, and which has the brick color institutional white, and which is neon. And this one is going to be inside of our right hand. And then we are creating a new part, and this new part is going to be very similar to the first one. It is also a ball. It is slightly bigger by 0.10 studs maybe. It is also institutional white, and the material is force field, alright? And we're going to tween the second one, and it is going to repeat itself and reverse itself, and within this reversal process, it is just going to change its transparency to 0.8 and then back to 0, alright? So you have to imagine that we have this Gura part, let's say, where all the earthquake force is bundled into, and this one has an inner core, which is the first part, which is completely white, which is neon, which shines bright, you know, and a second part is some kind of shell, which just changes the transparency, let's say. So this is all about effects again, okay? And then we have two welds. So the first weld is inside of our second part. I don't know why I have done it that way, but yeah, that's just how I've done it. So a weld inside of our second part. And part 0 is the part you are welding something onto. In this case, it is the second part's parent. And if you take a look at the second part's parent, it is the first part, alright? So the second part is located inside of the first part, okay? And the second part is also welded onto the first part. And part 1 is the part you're welding, alright? Which is the second part in this case. Now let me repeat it once again. We are welding the second part, so the shell, onto our first part, which is the core, and which is also the parent of the second part. Now, next weld right here, this one is located inside of our first part, and this one is locating the first part to its parent, which is which is the performer's right hand. All right. So part 0 is the right hand, and part 1 is the core part. Now, game debris add item, so it basically deletes the item inside of here after those amount of seconds. So X is being deleted after 2 seconds, and the same thing happens right here. So the second part is deleted after 2 seconds. That's basically what happens right here. Now, what we have right here is that we have a part called jump particles, all right? And I've totally forgot to say that, but shout outs to... Wait, jump sound? Ah, yeah. Yeah, shout outs to the person who has created this those particles, right? I can't remember who that was, but I only say that those particles weren't made by me, all right? That's just all I can point out so far. Now, we have a sound right here, and we have some particles, and we have this part. What happens is that... Yeah, what happens is that... So I had to go AFK once again. So what happens is that we are cloning this part, and then we are parenting it to our character, and then we are welding it to our humanoid root part. Yeah, we are welding to our humanoid root part, and then right here we are applying a C-frame, alright? And this C-frame is making this jump particles part go below our feet, or onto our feet level, and then we are also going to rotate that jump part by 180 degrees on the z-axis, alright? So that this happens. Let me show you what I'm talking about. Now wait, why am I not able to do this move? Come on, man, I was pressing Q. Ah, it was because I didn't really look into someone. Nah, look, as you can see, now you cannot really see it, right? Wait, let me move it right here then you can see it better. So, as you can see, those particles, they get smaller as they come to this side, alright? And this is basically the rotation I've done, okay? Because once I've cloned this and spawned this into the workspace, it literally was facing the wrong way, alright? So it was facing this way, but I wanted it to face the other way around, okay? And that's the reason I had to rotate this by 180 degrees, as we've done right here, alright? Now right here, local A refers to an animation track which we have loaded, alright? So we are referring to our performers, characters, humanoids, animator, and we are loading an animation by this animator right here. And this animation we are loading is this one, Gura jumps. So basically some kind of dashing animation, alright? And we are playing that animation. And right here we are also playing something called jump sound, which is inside of this jump part. Okay, and this is some kind of explosion sound, so it just appeals to this dashing. Now right here I'm creating a coroutine, and what this coroutine does is that everything inside of here is running apart from the rest, so it does not interrupt any further progress right here. So we have a loop inside of here, and we have a wait, all right? And this wait could eventually just create some kind of delay, okay, when we would not put this inside of a coroutine. That's the reason why we are putting it inside of one, so that we can make this code run apart from the rest. So what happens down here is that we are checking whether the holder of this local script right here is also the performer. And if that is the case, then we are going to do some camera movement right here. So we are doing a loop which loops 30 times. We are having some random variables right here, so x, y, and z. And each axis or each variable generates a random number from -1 to -100 to 100, and then divides this by 200. All right. So we just receive some random ass numbers right here, and then we are putting those random numbers inside of here. And this part right here, so performer, character, humanoid, camera offset. So we are referring to our camera offset, and we are applying those random numbers right here, and this causes this camera shake. All right, so those random numbers being put inside of here, and this over 30 times causes this camera shaking effect you guys can see. After this loop is done, we are reverting our camera offset back to 0, 0, 0. Okay. Now right here we are waiting 0.25 seconds, probably because of the animation to really start playing. And then we are creating a body velocity inside of our humanoid root part. And this body velocity is at the end responsible for us to be able to dash forward, alright? So we are applying a max force, which is math huge, so just very, very high, right, in numbers, of course. And then we are setting the body velocity to our humanoid root parts look vector multiplied by 50, alright? And then we are waiting, so repeat wait, until the distance in between our targets, so target humanoid root part position, minus performer character humanoid root part position, so the distance in between the target and us, is not greater than 5. Okay, and if that's the case, then we are disabling this Gura dark effect right here, which we had. So this one is being disabled, and then Gura blue is being enabled, because we have now, so at this point, we have now reached the phase of, so we are formally dashing towards the target. And once we are very, very close to the target, we can now switch over to punching the target. So that's basically what is happening now. So we are changing this effect, we are destroying the body velocity, we are destroying those jump particles, and we are stopping this A loader, so this A animation loader right here, which was responsible to play this Gura dashing animation, okay? And we are now coming up with another variable, which is also called A. So this might be a little bit confusing. I'm very lazy to change up the name. So A right here and A right here, okay? But just regard this as A now. And this one is also going to be an animation track, which are going to load via our performance animator. And this time we are going to load a Gura punch animation, okay? And then we are making a play. Yeah, right here we are creating another part inside of our performer character's right hand, which is going to be a ball, which is going to be anchored, which is not going to cast shadows, which is going to be Cancolite Falls, and which is going to be located inside of our which is going to be located at our humanoid root part C frame. All right, and it is going to be institutional white, and its material is going to be glass. Okay, and we have now set up a tween, and this tween makes this part increase by size, so by 20 right here, and it is going to turn this part transparent, and everything within 1 second. And after this tween is done, this part is being destroyed. So this is just some effects right here. All right. Now we have another coroutine playing, and this is once again a camera shake. All right. So as we have had it up here, with the only difference that we are not only looking out for the performer, but also for the target. So if the holder of the script right here is either the performer or the target, so what we only have of the target is the target's name, okay? And what we're doing right here is that we are checking whether a player exists inside of that player's tab, which also has the target's name. And if that's the case, then we want to apply this camera shake on the target as well, okay? Now down here, X2, we are referring to replicated storage, and then to something called crack. And we are cloning this one, and we are putting it inside of our parent. We are parenting it to our workspace, and then we are setting the C frame to our target human root part C frame, multiplied with some angle so that this crack right here stands upright. All right. Otherwise, it would stand weirdly because of the rotation whatsoever. Now we have a sound right here called Gura. It is being cloned from our local script, and it is being put inside of this crack effect right here, and then it is being played. And right here we have another tween, which makes this crack right here vanish. So transparency 1 within 1 second, and once it has completely vanished, we are destroying it. And right here, we are setting the target humanoid root part C frame to a new C frame right here. And this part right here is just rotating the target's humanoid root part towards our performer's humanoid root part. Okay? And you might ask why, because I wanted to add some kind of knockback, alright? And I wanted the target to knock back into the direction our player was facing to. Okay? That's basically what happens right here. And this is the same concept as up here, alright? Now down here we are adding a body velocity inside of our target now. And this target, and this body velocity is going to make our target, you know, move into the direction our performer's character's humanoid root part was facing to. And, well, yeah. Let's add something to this, because otherwise we will have some problems. So, game debris add item. So we are going to add this body velocity into the debris after 2 seconds. So it is going to vanish after 2 seconds. And down here, we are now making our targets, humanoid root part's walk speed and jump height revert, and the same thing goes for our performer. And after 0.5 seconds, we are disabling this Gura blue effect right here. And that's it with the video, guys. I hope you have enjoyed it. If so, leave a like, subscribe, share this video to all of your friends, leave me feedback in the comment section, guys. Take care and see you in the next video.